So to solve an equation means to get x alone. So that's what we're going to be working with. We just have logs that are in the way. So we want to get x alone, but when we do it, we can only use a legal math move on both sides of the equation. So as long as what you're doing is legitimate, you should be able to work towards getting x by itself. So we're applying onto both sides. That's what solving means. Now we've learned solving with a quadratic formula, we've learned solving with factoring, we've learned solving with using square roots and all kinds of absolute values. Always about getting x by itself. So we're going to start with some fairly gentle examples, and we'll work our way through each time. We'll sort of increase the difficulty level till we end up with some of the more challenging ones that you're going to see. So we'll start with this one. It's fairly benign. Log base of 3 of the problem x plus 4 to the third. Our job is to solve for x, so get rid of things so that we can have x by itself. So the first thing we want to get rid of is a log. And we just have to think of the legal way to get rid of a log. You can't subtract a log. You can't divide a log. You got to have some way of getting that log to cancel out. So from the last couple days, how do we cancel out a log? What would make a log drop out of a problem? We've done it before. Okay, we've seen logs cancel out. Any ideas? Okay, this logarithm right now. Well, what's the base? We need to make the bases match. 3. Okay, the base is 3. So what we're going to do is like shrink this down to a little small problem, okay, and we are going to introduce the base of 3 on both sides. This is called exponentiation. You don't have to know the fancy word for it. But what it does is it shrinks each side. So we've got big 3, and now we have little log base 3 of x plus 4. And on the other side, big 3, and we shrunk it down to little 3. So what you're doing is you're introducing the same thing legally on both sides. And on the left side, that big 3 cancels out the log base 3. And that resizes x plus 4 back to normal size. And on the other side, what do we have? 27. So the answer is 23 when you subtract 4 from both sides. That's the whole idea of this lesson, is that you're going to introduce a base on both sides, the right base, make sure you choose the right number, that will cancel out the log, shrink things down, and then resize them so that you can solve on both sides. All right, let's try another one. All right, suppose we have the logarithm base 5 of parentheses 2x, and then we have a minus 1, and that's equal to 2. What do we do first to both sides? Add 1. Okay, we want to add 1. We got to take care of that minus 1 first. So that'll give me 3. The next thing I want to get rid of is the log. So I need to choose the right number to introduce on both sides so I can get rid of that log. Okay, now I'm going to choose the number 5. So I'm going to use a great big 5 on both sides. So what I've got is it basically takes the log and it shrinks it down to a tiny exponent, and then I have 5 to the third. So on the left side with the log, the big 5 cancels out the log base 5 and resizes that 2x to normal size. And what do I have on the right hand side? 125. Okay, that is 5 to the third. And then I divide both sides by 2, so the answer is 125 divided by 2. Please don't turn that into a decimal. It doesn't reduce. We're just going to leave it 125 over 2. Okay, how are we doing? Questions so far? Okay. Each time we're going to introduce something new. let's try this one. 4 plus the natural log of 2x equals 3. Just make sure you're doing legal things to both sides. Okay, Kat, what would you do first? Yep. Okay, I'd subtract the 4 also. So we're going to subtract the 4 to both sides. That'll give me a negative 1. Now I want to get rid of the log. So now choose well. E. Okay, E is the right choice. That's the only thing that will cancel out that logarithm. So I'm going to use a base E on both sides. What it does is shrinks down the natural log 2x, and it shrinks the negative 1. So that E cancels out natural log and resizes 2x. And now e to the negative 1. Okay. We talked about negative powers and what they do to their bases. Okay, so I think, Hayden, you were on the right track. Okay, it's going to be 1 over something. Remember, negative powers don't mean negative numbers. Negative powers means the number becomes a fraction, and the fraction would be 1 over e. Now how do I get rid of the 2? Because I need to get x by itself. How do I say it again? Divide, or I would multiply by the reciprocal, actually, probably what I'd do since I'm dealing with fractions here. So I'm going to multiply both sides by the reciprocal. That's multiplying it by half, and that's multiplying the other side by half. That gives me x by itself, and it gives me 1 over 2e as my answer. Okay, how are we doing so far? Okay? Yeah, I don't want decimals, fractions. Yep, fractions. Unless, of course, the fraction can be reduced to something simpler. All right, let's try another one. Okay, what if you have the log of the quantity x squared, and that's equal to 4? Okay, the log of the quantity x squared, and that's equal to 4. Okay, what do I do first? Jason, got an idea? All right, we're picking 10. Good choice. We're going to pick 10 for our base on both sides. That's going to cancel out my log, and I'm going to resize my x squared. And 10 to the 4th is 4 zeros, 10,000. Okay, now what do I do to both sides? I take the square root, but what goes in front of every single square root? Okay, it is the plus or minus. So we want to have the plus or minus square root of 10,000, which is reducible because 10,000 is the perfect square of something, and that is the perfect square of 100. So the answer is plus or minus 100 in this case. Okay, how are we doing? Questions so far? Things you're confused about? Okay. All right, let's introduce something new now. All of the problems we've done, the first 4, have only had one logarithm that we had to deal with. Now what happens when we got to deal with 2? So the logarithm base of 4 of 3x plus 2 equals the logarithm base of 4 of 6 minus x. Okay, we now have 2 logarithms on each side. That's the limit. You cannot have any more than 1 log on each side of the problem. If you have more than that, then you're going to have to do some other properties to get rid of some of them. But you can only have 1 log on each side. You may have 1 on each side, or you can have 1 and none, but you cannot have any more than that. So let's just focus on the log on the left. How would we get rid of that? Base 4. Okay, so we'll use base 4, but whatever you do on the left, you have to do on the right. And it works out great for us that the log on the left and the log on the right are both going to get canceled out with the base of 4. And that works to my advantage because they were matching bases. They both were base 4. So that's going to resize the 3x plus 2 and the 6 minus x into just a basic algebra problem. We'll add x to both sides, so 4x plus 2 equals 6. We'll subtract the 2, and so x is 1. Okay, but just remember what your limit is. Your limit is no more than 1 log on each side. So this next question's gonna exceed the limit, and I'm gonna show you how to handle that then. So if you've got the logarithm that's negative 2x plus 13 minus the logarithm of 6 equals the logarithm of 4x. So now we've exceeded the limit. We've got 2 logs on the left-hand side, 1 log on the right, and that is more than what we are allowed if we're going to solve a problem. All right, so I'm open to suggestions, ideas you have. You've got 2 logs on one side. What do we do? Okay, one at a time. Okay, she says use the division property. Brandon? Base 10. Okay, I can't. I got more than, I cannot do that. You are not allowed to do base 10, base 10, base 10. That would be illegal of what you're doing. You cannot do more than one at a time. Okay, so division, what would you divide? Say that again? I don't know why this isn't erasing. And divide it to where? Okay, so you had the same idea as Maya. You're right. We're going to use the division property. Why isn't it catching up? Hang on. Okay, so Maya and Mariah both came up with the idea of using the division. Subtraction is the same as putting the pieces back together into an addition problem. So we want to put these pieces back together. So negative 2x plus 13 is going to be divided by 6. Then we can use Brandon's idea. Okay, Brandon's idea was to use base 10. But you can't use Brandon's idea until you have no more than 1 log on each side. So we're using division first, and now we're going to use base 10. That base of 10 will cancel out the log on both sides, and I'll be left with the resized negative 2x plus 13 over 6 being equal to 4x. When you've got a fraction on one side and not a fraction on the other, I always recommend dropping a 1 on the side that didn't have a fraction because it's easier to cross multiply that way when you do that. So when we cross multiply, we'll now have negative 2x plus 13 being equal to 24x, and we can solve that with just a couple steps. But our barrier at the beginning was having too many logs. We're going to add 2x to both sides. That gives me 13 equals 26x. And when I divide both sides by 26, I get x to be half. Okay, any questions so far? We've got a couple more, and they are each going to get, a little bit, another step and another step. All right, when you tackle this one, here's another one with too many logs. We're going to have the ln of 3x minus 2 plus the ln of x minus 1 being equal to 2 ln x. So we actually have 2 violations here. We've got too many logs on one side, and on the left-hand side we have a coefficient that's sitting there that we can't have either, that 2 right there. So you can't have any more than 1 log on a side, and you can't have any numbers sitting there in front of the log. So let's deal with the left side because we've got 2 logs right there. What property can we use to condense that? Multiplication. Very good. So we're going to use multiplication because in logarithms land, in logarithm, multiplication and addition are equivalent to each other. How do I do multiplication though? What am I multiplying? I'm multiplying 3x minus 2, multiplying 3x minus 2 with x minus 1. What's the right way to multiply those together? FOIL. So I'm using FOIL within logarithms. The addition becomes multiplication. So I'm going to look at 3x squared minus 3x minus 2x plus 2. On the right-hand side, the thing I have to correct is the issue with the 2. I can't have that 2 there. It's got to start with ln. That's got to be the first thing. So what do I do with that 2? Move it where? Where did it come from? Where does it belong? Okay, it belongs as a power, right? This 2 belongs as a power, so we're going to put it back where it belongs. Now I have no more than 1 log on each side, and both sides start with that log. Can't have anything in front of the, it has to be starting with the log. Now, what base can I use to clear out my logs? E. So I'll use base E on both sides. That'll clear out both of my logs at the same time. That's going to leave me with 3x squared. I'm going to combine those two and make negative 5x plus 2 equals x squared. All right, what's the legal thing to do now at that point to solve that problem? Why do you do that? You're right. Why do you do it? You want to make it equal 0. Okay, so we're going to subtract the x squared from both sides because we want to make it be equal to 0. Once it's equal to 0, we've got some options. We can star. We can use the quadratic formula. These are our ways to solve squared problems. Let's try star. Top of the star would be 4 and the bottom is negative 5. So the numbers that work on that are negative 4 and 1. That does not mean negative 4 and 1 are the answers. That means that negative 4 and negative 1 replace the 5, and then you split factor. But there are still some of you who continue to use your star wrong. You get the star numbers, and then you just think that those are your answers. They're not. They're an intermediary. They're part of it. So then we're going to take out 2x, leaving me with x minus 2. I'll take out negative 1, also leaving me with x minus 2. So my factors are x minus 2 and 2x minus 1. Both of those are equal to 0. These are factors. Set them each equal to 0 and get your solutions of 2.5. So this is like everything all together. It's logarithms, it's squares, it's factoring, it's setting things equal to 0. It's everything all together. Okay, we have one final question. And I figured out who we're missing. It's Nate Newbold. He was at the Packers game in Green Bay last night. I know. Too bad they lost. All right, last one. 1/2 log 2x equals log x plus 4. I'm okay with the number of logs here. There's 1 log on the left, 1 log on the right. That's totally fine. What's the problem? The half. Okay, the half is my problem. I can't have it there. Okay, some people say times it by 2, get rid of it. Okay, I can times it by 2, but then I got a 2 on the other side. Now I just moved the problem to the other side. So how do I actually deal with the problem? Okay, put it back. Okay, put it back. You can either put the half back in the right place, or now that we've got the 2 on the other side, you can put the 2 back in the right place. Okay, but at least at some point you got to move that power back to where it belongs. So we're going to have log of 2x being equal to log of x plus 4, and then the squared will be on that. Now we're fine. Now we've got 1 log on each side, nothing in front of either of the 2 logs, and so now I can actually use the right base. What would be the good base choice here? 10. Good job, Maya. All right, so 10 on both sides because of that base being 10. That will leave me with 2x and resizing x plus 4 squared. And please don't make the simple mistake of squaring x plus 4 incorrectly. Some people in your rush, you'll say x squared plus 16. But that's not the right way to square x plus 4. Okay, so don't rush through that. The correct way to square x plus 4 would be to have x plus 4 foiled with a second x plus 4. That's the right way to do that. So you end up with x squared plus 4x plus another 4x in the middle, then plus 16. So altogether, you'll have x squared plus 8x plus 16. And then you set it equal to 0, You'll have x squared plus 6x plus 16. And you try the star on that. Okay, are there any numbers that 16 and 6 work when making a star? I wish I could do 8 and negative 2. That'd be great. But that doesn't make positive 16. And I can't really think of anything else. So what does that mean my only option is at the end? Quadratic formula. So to finish up, whoop,